Hello viewers, and welcome to today's episode, which deals with the concept of a function and the various types of function, uses of various functional relationship in business and economics. In addition to it, the script also explains the difference between a constant and a variable and characteristic of a function. I myself is Nilofer Zirgam and teaching in the Center for Management Studies, Jamia Millia Islamia University, New Delhi. Today we'll take a broad overview of a concept of function and the various types of functions. To begin with, let's start with the concept of a function. The concept of a function is fundamental in business and economics. The term function is used to describe relationship that exist between variables. For example, the price of a product and the quantity demanded for the product, or the demand of a product and seller's revenue, or the firm's production and its total cost of production. If two variables, call them x and y, are so related that whenever a value is assigned to x, one value of y results according to some rule, then y is called as a function of x and is expressed symbolically as y equals to f of x, where x is independent variable and y is a dependent variable. The set of all possible value that x can assume in a function is called the domain of the function, and the set of the values that y can assume in is called the range of the function. The variable x and y were arbitrarily chosen, and more appropriate letters can be used when desired. In mathematical economics, a variable is often represented by the first letter of its name. For example, the symbol for investment is generally capital I, for savings it's capital S, for price is small p, for quantity it's small x, or you can take small q, for total cost it's capital C, for average cost it goes as capital AC, for income it's capital Y, for total revenue it's capital R, and so on. Let's see what is a constant and a variable. Before defining a constant and a variable, I would like to define you what is a quantity. Quantity is anything which is capable of being measured is called a quantity. In general, all those things on which the operation of mathematics, that is addition, multiplication, subtraction and division, can be performed are called quantities. For example, area, volume, distances are all quantities. Now let's define what is a constant. A quantity which retains the same value during any set of mathematical operation is called a constant. Constants are generally denoted by the first letters of alphabet, that is A, B, C, etc. A constant may be absolute or an arbitrary constant. An absolute constant retains the same value in all problems. For example, under root 2, pi, e, etc. These are all absolute constants. An arbitrary constant retains its value in one problem but may assume a different value in different problems, such as bonus or wage in different industrial organizations, etc. Now let's see what is a variable. All those quantities which are capable of assuming various values during any set of mathematical operations are called variables. Variables are usually denoted by the last letters of alphabet, that is x, y, z, etc. For example, the two variables a and r, which denote the area and the radius of a circle, are related to each other by the formula, which is a equals to a pi r square, where pi is a constant. The value of a depends on the value of r here. As r increases, the corresponding value of a also increases. Here the variable r is called the independent variable, and variable A is called the dependent variable. A variable, on the other hand, can be either continuous or discrete. A continuous variable is one that may take any numerical value within a specified interval of real numbers, whereas a discrete variable is one that may take only values in a specified countable range. For example, number of integral value in any specified interval on the real line is countable. Let's see an example. If f of x is equal to x square minus 5x plus 6, then find the value of f of 0, f of 2 and f of minus 3. The solution to this can be f of x equals to x square minus 5x plus 6. So this implies that f of 0 can be written as 0 square minus 5 into 0 plus 6, which is 6. F of 2 can be written as 2 square minus 5 into 2 plus 6, which is 4 minus 10 plus 6, which equals to 0 finally. Now f of minus 3 can be written as minus 3 square minus 5 into minus 3 plus 6, which ultimately comes as 30. Now let's take a second example. If f of x equals to 2x square minus 5x plus 4, for what value of x is 2f of x equals to f of 2x? The solution to this can be given as f of x equals to 2x square minus 5x plus 4. Now 2f of x can be written as 2 into 2x square minus 5x plus 4, which is 4x square minus 10x plus 8, and let's make this equation 1. Now f of 2x can be written as equals to 2 into 2x square minus 5 into 2x plus 4, which is equal to 8x square minus 10x plus 4. Let's make this equation second. Equating equation 1 and 2, we get 4x square minus 10x plus 8, which is equals to 8x square minus 10x plus 4. This implies 4x square minus 4 equals to 0, which implies 4x square equals to 4, and this is x square equals to 1, which ultimately gives x equals to plus minus 1. Now let's see how a function is related to business and economics. The concept of function is fundamental in business and economics. The term function is used to describe relationship that exists between variables. For example, the price of a product and the quantity demanded for the item, the demand for the product and a seller's revenue, or a firm's product and its total cost of product. One of the major objectives is to move from the demand of a product to a firm's revenue, then to move from the firm's cost function, and finally to obtain and maximize the firm's profit function. Now let's see some important types of functional relationships which are commonly used in mathematical economics. The first one is the demand function. Now let's see what is a demand function. The relationship between the quantity given by X of a commodity demanded and the price given by P is called a demand equation. A mathematical expression for a demand equation can be written generally as X equals to f of P. The function f here is called the demand function, and f of P is the number of units of the commodity demanded, for which P is the price per unit of the commodity. In other words, demand function is a functional relation between the number of units of a particular commodity and demanded in the market, that is the number of units that can be sold, and the price per unit. For example, P equals to 3200 minus 4x is one of the demand function. Other example for a demand function we can take as q equals to 7p square plus 8p plus 18. So these are some example of demand functions where p or d of x is the price per unit and x or q is a number of units that can be sold at that price. Now here comes next function, which is supply function. The relationship between the quantity given by x of a commodity supplied and the price given by p is called the supply equation. A mathematical expression for a supply equation can be generally written as x equals to g of p, where the function g is called the supply function and g of p is the number of units of the commodity supplied, for which p is the price unit of the commodity. In other words, supply function is a functional relation between the number of units of a particular commodity that sellers can supply at a given price. Let's see some of the examples for supply equations. For example, x equals to 6p plus 5, or x equals to p square minus 7p plus 2, or q equals to 650p are some example of supply functions, where p is the price per unit and x or q is the number of units available in market at that price. The next one is cost function. What is a cost function? The relationship between the output, which is given by x of a commodity, and the total cost, which is given by capital C of a commodity, is called a total cost function. A mathematical expression for a total cost function can be written generally as capital C equals to f of x. Also, cost function, that is C of x, represents the total cost of producing x items. The total cost consists of two parts. The first part is the fixed cost, which is given by capital F, and the second part is the variable cost, which is given by V of x. Fixed cost includes office expenses, cost of machines, wages of permanent staff, insurance, and etc. Fixed cost is there even if there is no production, whereas variable cost includes cost of direct labor, cost of material, cost of transportation of the material, etc. So in total, the total cost can be given as C of x equals to capital F plus V of x. For any given demand function, x equals to f of p, where p is the price per unit and x is the number of units. So total revenue is given as R of x is the product of p and x. That is, R of x equals to total revenue, which is given by p into x, which can also be written as p into f of p, where p is the price per unit of the commodity and x is the number of units of the commodity sold. Let's come to profit function. Now, what is a profit function? The profit function is defined as the difference between the total revenue function, which is given by R of x, and the total cost function, which is given by capital C of x. If we denote the profit by capital P, then P of x is given as R of x minus C of x, where R and C are the functions of x. Let's define what is an average cost of production. Average cost of production, which is denoted by capital A of x, is obtained by dividing the total cost by the total number of units produced. So A of x can be given as C of x divided by x, where x is the quantity sold. Now, what is a utility function? For utility analysis, we defined a function which represents total utility, which is given by capital U equals to f of x. It shows how much utility an individual obtains from consumption of different amounts of a good. When the amount of a consumed good, capital A, changes, the individual's utility also changes. The change in the total utility when one additional unit of good A is consumed is called as marginal utility. At any point of x of the utility function, we can measure the rate at which the total utility is changing by the derivative of the function. For example, if total utility is given as capital U equals to 15.6x minus 0.80x square, then marginal utility, which is given by capital MU, can be obtained by differentiating U with respect to x, which is given as 15.6 minus 1.6x. Let's discuss few of the characteristics of a function. First one, a function may be undefined for some value or values of independent variables. For example, f of x equals to x plus 4, the whole thing divided by x square minus 2x minus 3 is not defined at x equals to 3. Second point, a function is called even if f of x equals to f of minus x for all the possible values of x. A function is called odd if f of minus x equals to minus f of x. Third point, let a, b be two numbers in the domain of a function such that a is less than b. In that case, if f of a is lesser than f of b, then this implies that f of x will be an increasing function. If f of a is greater than f of b, then this implies that f of x will be a decreasing function. By an increasing function, we mean that f of x increases whenever there is an increase in x. In a decreasing function, f of x decreases whenever x increases. However, if the function is neither an increasing nor a decreasing function, f of x does not change with the change in the value of x. Let's see different types of a function. The first one is, let's take constant function. A function of the form f of x equals to capital C, where capital C is a constant, is called a constant function. Thus, to each value of x, f gives the same value, which is C. The second function comes as identity function. A function of the form f of x equals to x is called an identity function. Thus, the identity function associates to each real number x the same number x. Let's define the third function, which here comes as linear function. A function of the form f of x equals to ax plus b, or you can write this as y equals to ax plus b, is called a linear function, where a and b are the constants here. Here y is said to be a linear function of x. The graph of a linear function is always a straight line. For example, f of x equals to 3x plus 6, or y equals to minus 9x, or y equals to 10 minus 4x are some examples of linear functions. Now let's see what are quadratic functions. A function of the form f of x equals to ax square plus bx plus c, where a, b, c are constants and a is not equal to 0, is called a quadratic function. For example, f of x equals to 3x square minus 9x plus 4, or y equals to minus 4x square plus 5, or y equals to 7x square plus 4x are some examples of quadratic functions. Graph of a quadratic function is always U-shaped and it is called a parabola. Now let's see what are exponential functions. It is a function in which independent variable appears as an exponent, that is power. For example, y equals to a raised to the power of x, or y equals to 3 raised to the power of 2x plus 3, etc. are all exponential functions. Y equals to a raised to the power of x, where a is the positive real number and a is not equal to 0, is the most popular exponential function. It is an increasing function, that is, as the value of x increases, the value of y increases when a is greater than 1. It is a decreasing function, that is, as the value of x increases, the value of y decreases when a is lesser than 1. Now let's see what are logarithmic functions. A function of the form y equals to log of x, where to the base of a, where x is greater than 0 and a is also greater than 0 and a is not equal to 1, is called as a logarithmic function. a is called the base of the logarithmic function here. When a is 10, it is of the form y equals to log of x to the base of 10 and is called as a common logarithmic function. When a equals to e, it is of the form y equals to log of x to the base of e and is called as a natural logarithmic function. So that brings us to the conclusion. Now let us quickly summarize what we have learned today. We have learned the concept and the significance of function and the various types of functions, uses of various functional relationship in business and economics. In addition to this, the script also explains the difference between a constant and a variable and the characteristic of a function. That is all for today. Hope you have understood the meaning of functions, constant and variables, different types of functions, their uses in business, commerce and economics, and linear and quadratic functions in detail. We'll see you again discussing more about logarithmic and exponential functions. Till then, take care. Bye.